Hi students, this is Ramesh, lecturer in physics in Nilagiri Degree and PG College. In last class, we are discussed already postulations of special theory of relativity and what are the inertial frames and non-inertial frames. Today, we discussed the Galilean transformations. Galileo transformations. These transformations depends upon the frames, reference frames. But quickly revise the what is inertial frame, what is inertial frame, what is non-inertial frame. We say that which frames are obey the Newton's laws. Those are called inertial frames. Which frames do not obey the Newton laws or Newton mechanics. Those are called non-inertial frames. So, Galilean transformation gives the majorly convert the one reference frame coordinates into the another reference frame coordinates. Basically, there are position and time is changing from one to transfer one frame to another one. See here, Galilean transformations are used to the transform the coordinates of position and time from one inertial frame to other. Suppose we consider S is a inertial frame that coordinates are x, y, z. And we consider another also that is s dash. This is moving relativity to with respect to s. That coordinates are x dash, y dash, and z dash. In an event occurred in a s dash in a space that is observed by the s. That is observed by the s. What are the coordinates of event at point P from s, x, y, and z in three-dimensionally? Another is the time coordinate t. But what about s dash? How to recognize that event in s dash, x dash, y dash, and z dash, and t dash? These are the coordinates according to s dash. So what are the relation between s and s dash? That is derived from the Galilean transformations. So see here, consider a frame s and s dash. Let the velocity of s dash is related to the s is v. Consider an event happening at p particular time t. Let the coordinates of p with respect to that event are observed x, y, z with respect to time t. At the same event observed in s dash, that coordinates are changed. What are that? X dash, y dash, z dash, and t dash. So Galilean make the this relation between s and s dash gives these equations. So from the figure we know that what is the x. From the figure we know that these are the distance of x from s. So x is equal, we simply write that x dash plus what is this distance. So write the velocity. What is the formula? Velocity distance by time or displacement by. So what is the distance? T is equal to Vt. So we write the d place replace with Vt. So that's why here draw Vt. Okay, Vt. So write the x value from diagram. X is equal to x dash plus d. D nothing but Vt. So what is the x dash? Simplify this, x dash x minus Vt. As there is no relative motion along the z and y and z axis, so though no change in coordinates of y and z, so we simply write y dash is equal to y, z dash is equal to z. And also in classical theory consider, or classical physics consider, time does not change. So t dash we write the t space coordinate. Therefore, write the four equations in orderly. X dash is equal to x minus vt, y dash is equal to y, z dash is equal to z, t dash is equal to t. These four equations are called Galilean transformation equations. What we learn from the Galilean transformation equations, what is the information give that? That position is changing. So x dash is x minus vt. Okay. T dash is equal to t. That will becomes Galilean transformations. These equations are Galilean transformation equations. What right? Sometimes they are asked, what are the inverse? That means we write the s coordinates LHS in LHS side and y s dash coordinates in RHS side. So x is equal to x dash plus vt, y is equal to y dash, z is equal to z dash, t is equal to t dash. These are the inverse. But what are the Galilean transformations? When we write the LHS in S dash terms, that means x dash is equal to x minus vt, y dash is equal to y, z dash is equal to z, t dash is equal to t. These are the Galilean transformations, and the inverse are write the x terms are x, y, z, t terms are LHL terms. Okay. So we find the what is the velocity. We find the velocity. These are the relative velocity. We find also acceleration. A dash is equal to a vector. And what are the using of Gaussian transformations? When a reference frame, we consider two reference frames. One is a constant, another one is a moving with some velocity, constant velocity to the related to the first one. So what happens? The position coordinates and it will change. So we convert the x into x dash terms, right? X is equal to x dash minus vt. These are the Galilean transformation equation. These are most important transformations. But where it is applicable, Galilean transformation equations, two reference frames are moving with very small velocities and very low velocities. అంటే వెలాసిటీ అనేది స్లోగా ఉండి టూ రిఫరెన్స్ ఫ్రేమ్స్ అనేది ఒకదాంతో ఒకటి స్లోగా నెమ్మదిగా ట్రావెల్ చేస్తున్నప్పుడు మాత్రమే ఈ గెలియన్ ట్రాన్స్ఫర్మేషన్స్ అనేవి మనకు అప్లికబుల్ అవుతాయి. అంటే గెలియన్ ట్రాన్స్ఫర్మేషన్స్ ద్వారా మనం అక్కడ ఎక్కడైనా ఈవెంట్ అంటే స్పేస్లో ఈవెంట్ జరిగితే ఆ ఈవెంట్ యొక్క పొజిషన్ కోఆర్డినేట్స్ మనం ఐడెంటిఫై చేయడానికి ఆస్కారం ఉంది. కానీ when the event or reference frames traveling with more velocities like it compared to the light velocity, at that time the Gaussian transformations are not applicable. So Gaussian transformations equations are only applicable at very low velocities are having the two reference frames s and s dash. At very high velocities not applicable. Okay. This is the today our topic. But what about the when two reference frames are travel with light velocity or compared to the light velocity, what kind of reference frames are required, what kind of equations we require to express that position and momentum of the position and event that object. So we are using Lorentz transformations. What that are? Lorentz transformations. This is a very very important topic. The Lorentz transformations we can there is our applications there to there. One is length contraction, another one is the time dilation. According to Lorentz, when two objects are traveling with compared to the light velocities, that object's length appears to decrease. That are the length contraction. When an observer in a space, one observer is moving in a space and one observer observe the time in a space. The time is moving very slowly observed by the observer. That is the time dilation. That means time is increasing. When the length of the rod is decreasing, length contraction. These are the relativity So according to Lorentz, relativity occurs in length as well as time. So the topics are discussed later. Okay.